All right, so we are going to start talking about surface area today. So how I think about surface area, I've always thought about it like you're wrapping a present and it's how much paper you need if you didn't overlap at all. So the area of that paper. Another way you can think about it, we talked about nets yesterday. If you were to take a three-dimensional figure, lay it out completely flat into its net. And if you took the area of each of those individual figures and added them all together, that would be the surface area. So we're going to talk about how to find the surface area of two different things today. We're going to find the surface area of prisms, which is the fun one, and cylinders, which is pretty simple. So it's just plugging things into a formula. So let's start first about some vocabulary. First thing, a prism. A prism is a special polyhedron. So remember, a polyhedron from yesterday, three-dimensional figure whose faces are polygons. So this specifically is a polyhedron that has two congruent parallel faces. Okay? Those are called the bases. So yesterday, we had some of these where we had like a pentagon, and then the rectangles. That would have been considered a prism. But we did one yesterday that had, I think you had one in your homework that was an octagon and then 8 triangles. That would not have been a prism because there was no parallel base on the top. Okay, so a prism, how I think about it, has a top and a bottom. Okay, now you name a prism by the shape of its base. Now the bases you have to keep in mind are the parallel faces. Sometimes, not all of the time, are they actually going to be sitting on their bases, okay? They could be tilted and be sitting on their sides. So if you identify the bases, so for example, these bases here are pentagons, so this is a pentagonal prism. This one here, its bases are triangular prisms. Now, the bases, like I said, the parallel faces. The other ones, what I think about the ones kind of like on the outside, these are called the lateral faces. So the area around the outside, okay, that's the lateral faces, okay? Whenever we're finding the surface area today, we're going to kind of break it up into two parts a little bit. The first thing we're going to work on finding is the lateral area. So I just talked about the lateral faces. It's the outside. So if you took this prism and you laid it out flat and you were just looking at that lateral area, that lateral surfaces all laid flat, that would be the lateral area. Now, if you take the lateral area, okay, so the lateral area, and then you also have the top and the bottoms, and add those together, that would give you the surface area. Now, let's talk about those two individual pieces here. So, what this picture here does, it just kind of unfolds this rectangular prism for you and shows you in a net where the formula comes from. So this is the formula for how to find surface area, but let's talk about where it comes from. Notice it's kind of in two pieces there. So the first thing, you take this prism, okay, kind of open up the top and bottom so you start to lay it out flat. When you lay it out flat, there's kind of 3 chunks. There's this top, there's this middle part, and then there's this bottom. But this top and this bottom are just the top and bottom of the prism, which are congruent rectangles. So, if I'm trying to find the surface area, I really need to find the area of all of this and add it together, but what is in blue up here, they're the same. So once you find the area of that rectangle, you have 2 of them. So that part of the formula where it says 2b, that's why it's 2b, because there are 2 rectangular bases. Now, they won't always be rectangular bases. Sometimes they'll be triangles. Sometimes, if it's like a super fun problem, they'll be hexagons. But for this one, it's just rectangles. Okay, so questions on the bases, the 2b part. Now, the lateral area part. Anytime you take a prism and unfold it, we have the bases. If you unfold it like this, the bases are the top or the bottom. That lateral area is always going to unfold in a rectangle. It will always unfold into a rectangle. Because think about it. If you like cut this side here that's marked with an H, okay, that side's a straight line, right? And then you kind of unfold it. It's Once you straighten it out, it's going to be a straight line. So to find the area of what's in yellow up here, I need to find the area of a rectangle. Well, to find the area of the rectangle, it's length times width, base times height. The height is just the height of the prism. So to find the height of the lateral area, it's just the height of the prism. So to find the area of the rectangle, it's base times height. That's the height. Now I can see it. This is the base right here. You would take a plus b plus c plus c in this picture. Well, let's go back and see what a plus b plus c plus d are. A plus b plus c plus c. A plus b plus c plus d. If you go back to the original picture, when you take a plus b plus c plus d, what are you finding? The perimeter. You're finding the perimeter of that base. You're finding the perimeter of the rectangle. So when you unfold it and put all those sides right next to each other, the perimeter is your base. So to find the lateral area, to find the area of that big rectangle, you're going to multiply the perimeter by the height. And you add those together. Okay, we'll come back to the cylinder after we go over the prisms. Okay, so let's open up to the inside of your fold. If you didn't fold it, you can just fold it so this is on the front. And you should have a nice little book on the inside. So first we'll talk about prisms. We'll come back and talk about the cylinders. Okay, so first thing, an altitude. An altitude of a prism. It's the perpendicular segment that joins the planes of the bases. It just means if you have a base here and a base here, what's the height? It means you're going to go the shortest distance from the top to the bottom, you're going to go straight down. Sometimes it just means you're going to go right along the edge. Sometimes, like these ones here, if you take the shortest distance from there, it's not the edge, right? You have to go straight down, looking for the height. It's kind of like if I were to stand like this, or just like stand like this, right? You'd have to go straight down. You wouldn't measure me off to the side, right? Okay. Now the height of a prism is the length of the altitude. So you kind of think about those in the same way. The height of the prism, how tall is it? The altitude. Okay. Now we have two types of prisms. We're going to work mainly with just one of them. In a right prism. In a right prism, all of the lateral faces are rectangles. All of the lateral faces are rectangles, which means the lateral edge is going to be that altitude. It just means in a right prism, it's not tilted. It's not like a leaning tower of Pisa. Okay, just go straight up and down. Okay? In an oblique prism, some or possibly all of the lateral faces, they're non-rectangular. So that would be like these two right here. Just means in an oblique prism, it's going to be tilted a little bit. So this side here, that's not the height, right? That's not the height. You have to go straight down and figure out how tall it would be. Okay, we are going to be looking mainly at right prisms because we have this awesome, incredible formula to how to find the surface area of a prism. So, like we talked about on the front, there's kind of two pieces of this. You have to talk about the lateral area around the outside and then the area of the bases. You're going to add those two things together. So, let's start with this one here. So, we want to find the surface area of this prism here. So, to find the surface area, we are going to take the lateral area plus the two bases. The lateral area around the outside plus the top and the bottom, the two bases. Okay, let's start with the lateral area. Now remember the lateral area, if you were to lay this out flat, you would have the triangle on top, the triangle on bottom. But then what you would have is you would have this big rectangle in the front, and then next to it another rectangle, and then next to it another rectangle, right? So you have these three rectangles in a row. I need to find the area of those three rectangles, okay? So to find the lateral area, the formula for the lateral area is the perimeter times the height. Because if I were to lay it out flat, if I did base times height, the height would be that 6. But the base, right, all along that side would be this side, laid out next to that side, laid out next to that side. So I need to take something plus 4 plus 3. I don't know what that other side is. If I'm going to find the perimeter, I need to find that other side. This is where the fun part comes in. I have a right triangle. We know a couple of ways to find these angle measures of a right triangle. Any ideas what would be the easiest to do for this one? Pythagorean theorem. A squared plus b squared equals c squared. Unless you know for certain it's one of those special right triangles, which would mean I need angle measures, which other than the 90-degree angle I don't have. We're going to use the Pythagorean theorem. Remember, the Pythagorean theorem says that if I square the legs, which are the two sides that make up the right angle, it equals the square of the hypotenuse, which I don't have. So, to find CC, we're going to do 3 squared plus 4 squared equals c squared, which would give me 9 plus 16 equals c squared, which would give me 25 equals c squared. Square root it, we would get 5. So I have a triangle with sides 3, 4, and 5. So if I were to lay this out flat, it would be 5 next to a 4 next to a 3. So 5 plus 4 plus 3 would give me 12. So to find the lateral area, we would take 6 times 12, which is 72. Okay, that's one piece. Now, I need to find the area of one of the bases, and then we'll multiply by 2 because there's 2 of them. Now, if I look at those bases, what kind of figure are those bases? Triangles. How do we find the area of a triangle? 1/2 the base times the height. Now remember, with the height, we're talking about the height of the triangle, not the height of the prism. So with the triangle, we need to see that right angle coming straight down from one of the tops. So for this triangle, what could I use for the base? 4. Okay, if I use 4 for the base, if it sat on that side that was 4, how tall will it be? 3. So 1/2 of 4 times 3, which would give me 6. Okay, I have the lateral area. I have the area of one of the bases. To find the surface area, you take the lateral area, which we said was 72, plus, remember you have 2 of those triangle bases. So 2 times 6, which would be 72 plus 12, which would be 84 centimeters squared. Okay, we're still talking about area. Area is always squared. Okay, so the prisms are the fun part today because this base was a triangle, but some bases are going to be rectangles, some bases are going to be regular polygons. So that's the part that can get kind of tricky today. The cylinders. So let's jump back to the front so we can talk about the cylinders. Now, to find the surface area of a cylinder, it's actually, in a way, the same formula. You're going to take the lateral area plus both bases. Here's the difference with the cylinder. I told you with prisms, the base, the shape of the base, sometimes it's a triangle, sometimes it's a square, sometimes it's an octagon. If it's a cylinder, what's the shape of the base? A circle! Always a circle. And if I need to find the area of a circle, we find the area of a circle the same way, regardless of how big or how small the circle is. So, to find the area of the base, you take pi r squared, but there's 2 of them. So that 2 pi r squared, that's what that is. That's both of the bases. Make sense? Okay. Now, for the lateral area, kind of like with the prism, I said if you lay a prism out flat, it's going to be a rectangle. If you take the label off a soup can and lay it out flat, what would it be? A rectangle. So we're still finding the area of a rectangle, and guess what? The height of this rectangle is still the height of the cylinder, right? Now, the base of this rectangle, what is the base of the rectangle? The circumference. So, to find the area of this rectangle, to find the circumference, you take 2 pi r times the height. So to find the circumference, to find the lateral area, it would be 2 pi RH. So once again, still kind of doing it in 2 pieces, but the cylinders are going to be much simpler. So let's go back. A lot of this vocabulary is going to be the same before we look at an example. A cylinder, a solid that has 2 congruent parallel bases. Both of them are circles. The altitude. The altitude is the perpendicular segment that joins the planes of the bases. The height is the length of the altitude. That's what we're going to actually plug into our formulas. And kind of like how we had right prisms and oblique prisms, we also have right cylinders. If it's a right cylinder, the altitude is going to be perpendicular to the bases. Just meaning it's not going to be slanted, right? Because if you slant it, this height, okay, is not perpendicular, right? That would not be perpendicular to the bases. So the other one would be an oblique cylinder. The segment joining the centers is not perpendicular to the planes containing the bases. So I told the last class, think about a slinky, right? If you had a slinky and you stood it up straight, that would be a right cylinder. If you had tilted the slinky, that would be an oblique cylinder. Okay, now, I think the cylinders are a little bit simpler because how with the prisms, you had to decide, okay, it has this kind of base. And depending on what kind of base it has, I need that formula to find the area of that base. But with a cylinder, all the bases are circles. So we have one formula, and you're just plugging numbers in. And I love the formula for the area of the cylinder, because you're going to take the lateral area. Remember, that's the rectangle. And the area of that rectangle is 2 pi r, the circumference, times the height. And then the bases are pi r squared, but there's 2 of them. So the surface area of the cylinder is 2 pi RH plus 2 pi r squared. Kind of has that ring to it, right? Okay. So we are just plugging numbers in for surface area. To find the surface area, we are going to take 2 pi r. What's the radius? 5 times h. Now the h is the height of the cylinder. If it was sitting on its bases, which it's not, so if I tilted it up, how tall would it be? 12 plus 2 pi r, which you said was 5, squared. Now notice in that first part of this formula, you can totally do pi times diameter instead of 2 pi rh. Okay, here we will leave it in simplest form with pi in terms of pi. So we'll take 2 times 5, which is 10, times 12, which is 120 pi. Here, make sure you square the radius first. 5 squared is 25. 25 times 2 is 50 pi. And remember what I said, I think last week? Although pi is not a variable, we can kind of in a way treat it like a variable. 120 pi plus 50 pi is 170 pi meters squared. So the cylinders are, I think, really pretty simple. Okay, let's get this glued into page 53. This is section 11.2, surface area of prisms and cylinders. The directions on the first one say use a net to find the surface area. Personally, I think that's a really great way to just kind of understand the formula, where it comes from. But in my opinion, we have these formulas for a reason, and it's much quicker and simpler to use the formulas. So if you want to try it by drawing the nets, go for it. But if you'd rather just use the formulas, I'm fine with that as well. That's probably what I would do, but totally up to you. So we are just going to use the formulas for our examples here. So 2 prisms and 2 cylinders. So the prisms can be the challenging ones. So let's start by drawing a triangular prism. Okay. So in this triangular prism, this bottom here is going to be 6 inches. This left-hand side is 10 inches. That long side is 24 inches. And then on the back here, it's going to be 10 inches. Okay, as a reminder, for a prism, to find the surface area, there's kind of 2 parts of the surface area. Okay, you have the lateral area. Okay, so the outside edges. And you have both bases. In this case, it's not the top and the bottom. It's the front and the back. Remember, your bases are going to be the parallel faces. Those are the only 2 faces that are parallel. So let's start with the lateral area. Now remember, the lateral area, it's as if you were to take this shape, and if you just unrolled it, it's going to be this outside here, right? So you would have, if you talked about this right-hand side, if you had this rectangle next to that rectangle, it'd just be 3 rectangles in a row, right? Okay. What's going to be the height of that big rectangle? 24, right? It would be 24 by, if we kind of like picture here, it would be that next to that next to that, right? It'd be the perimeter of that triangle. Now I see that that's 10 and that's 6. What's that side? Also 10. Now it's not 10 because of that side. It's 10 because of that side. So when I take 10 plus 10 plus 10, we would get 26. So my lateral area is 624. Okay, so that takes care of the big rectangle. Now I need the 2 triangles. So let's start with just 1 triangle. Now remember, to find the area of a triangle, it's 1/2 the base times the height. So if I look just at the triangle, so kind of thinking in 2 dimensions here. If I look just at this triangle, I have numbers that I could use for the base. Remember, for the height, you have to see that right angle because it has to be the perpendicular line connecting the vertex to the base. So what it would look like, if I were going to use 6 as a base, I would need to know that right there, which I don't. But what I do know, I know that this triangle is an isosceles triangle. So when I draw the height of this triangle, it cuts that angle in half. It also cuts that side in half. So kind of like that very first example we did, I have a right triangle. I have 2 sides. How can I find the third? Pythagorean theorem. Now be really careful here, because the Pythagorean theorem says if you take the sum of the squares of the legs, I'm missing a leg this time. So what we're going to do is we are going to take 3 squared plus, I don't know the other legs, so maybe I say x squared, equals the hypotenuse squared, which in this case is 10 squared, which would be 9 plus x squared equals 100, which would be x squared equals 91, which if you take the square root of that, it ended up being about 9.54. Just using the Pythagorean theorem to find the height of the triangle. Now we can find the area of the base by taking 1/2 the base. What's the base of my big triangle? 6. Times the height, we just found that, 9.54. We should end up with about 28.62. Okay, I have the lateral area. I have the area of one of the bases. We just need to add those together. So to find the surface area, we'll take the lateral area, which was 624, plus, remember I have two of those triangles. One of the triangles was 28.62. Make sure you multiply it by 2. Round it to the nearest whole number. It would be about 681 inches squared. Questions on the triangular prism? You guys are going to be so incredibly excited for this next one. Are you ready? I know. Okay, so this one is going to be a hexagonal prism. Ooh. Okay, here we go. A hexagonal prism. And it's going to be a regular hexagonal prism, which means all of those sides are congruent. One side is 5 centimeters, and then this length of the top is going to be 11 centimeters. Now, what I love about surface area, although this is a totally different problem, it's a totally different shape, we still use the same formula to find the surface area. We're going to take the lateral area plus both of the bases. Now remember, even though this is a hexagon that has a base, okay, to find the lateral area, right, it's as if you were to unroll this and you're going to have these 6 rectangles side by side, okay? The height of those 6 rectangles would be 11. And then if you're talking about the width, the base of those rectangles, it would be, right, if I laid it out flat, it would be this, next to 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 this. How long would that rectangle be? 30, right? 5 times 6, it would be 30. So the area of that rectangle would be 11 times 30, which would be 330. Now, let's talk about how to find the area of the base, because what kind of shape is my base? A hexagon. Does anybody remember how to find the area of the hexagon? So close. Half the apothem times the perimeter. That lovely word apothem, you guys thought it was gone away forever. It is not. It is back. I'll haunt us again. Okay? Remember what the apothem is. It's the distance from the center directly down to one of the sides. So, I can find the perimeter. I already found the perimeter. But I need the apothem. So remember what we did here is we created triangles. So I split this and this. And I created this triangle here. And I'm looking for the apothem. But what we also did is we first found this top angle here. So I took 360 divided by how many triangles? 6 triangles. So that means that this big angle is 60, but the apothem cuts it in half. So this angle here is actually 30. Also remember, this side is 5, but the apothem also cut that in half. So this side right here is 2.5. Now what I need to find is the apothem. Now this time I have a 30, 60, 90 triangle, so I can use the properties of these special right triangles. The 30-degree angle is right here. Luckily, that's my S, which is awesome, because how do you find the longer leg? Multiply by the square root of 3. So that height is going to be 2.5 square roots of 3. My apothem is going to be 2.5 square roots of 3. So to find the base, we're going to take 1/2. The apothem, we said, was 2.5 square roots of 3. And the perimeter? 30. Yeah, already found it. Okay, plug all that in. we should get 649.52-ish. And then once we have those two pieces, we'll plug them in. So to find the surface area, you would take the lateral area, which is 330, plus, remember we have 2 of those hexagon bases. So 2 times 649.52, which would give you about 1,629 centimeters squared. Okay, the prisms are much more challenging than the cylinders. Because the prisms, like we've seen, depend on what shape the base is. Okay? For a cylinder, all of the bases are circles, so it makes it much easier. Yes? Is that what? It's not a plane, it's a miraculous metal. Leave it there, you can leave it. Oh, just kidding. Okay, alright, so next thing we're going to move on is finding the surface area. These ones go pretty quick. We've only got a few minutes left, so let's go through here. So, number 3, let's draw a cylinder. Okay, and this cylinder is going to have a radius of 4 inches, a height of 6 inches. Now keep in mind that the formula for the surface area of the cylinder, it's the same thing. It's going to take the lateral area plus the area of the bases. But I can be a little more specific because it's going to be the same formula for every cylinder. To find the surface area, the lateral area will be 2 pi r, that's the circumference, times h, that's that rectangle, right? The length is the circumference. The height is the height of the cylinder, plus 2 pi r squared. The 2 pi r squared is one circle, but I have 2 of them. Find the area here, you just plug the numbers in. So we're going to take 2 pi, my radius is 4, my height is 6, plus 2 pi, my radius once again is 4 squared. Okay, 2 times 4 times 6 would give me 48 pi. Make sure you square your radius first. So 4 squared is 16. 16 times 2 would give me 32 pi. 48 pi plus 32 pi would give me 80 pi inches squared. Okay, we'll just do one more of the cylinders. Okay, so if I tilt this one, this is number 4, if I tilt this one on its side. Okay, this time let's say the diameter is 9 feet and the height is 11 feet. Same surface area problem. Now, the surface area, to find the lateral area, remember it's circumference times the height. For the last one, we used 2 pi r because I was given the radius. If you wanted to, for this one, you could do pi times diameter. Same thing as 2 pi r. If that confuses you, use 2 pi r. Make sure you multiply that by the height. Plus, you will have to do 2 pi r squared. So we're going to have to find out radius whenever it comes to the circles. And plug our numbers in. When I take pi times the diameter, which is 9, times the height, which is 11, plus 2 pi. What is my radius? 4.5 squared. So that would give me 99 pi. 4.5 squared times 2 would give me 40.5 pi. Add those together, you would get 139.5 pi feet